You've never seen Saturn like this before. James Webb's stunning revelation. For generations, Saturn has captivated astronomers and dreamers alike. With its majestic rings and mysterious moons, this gas giant has always seemed a world apart, both awe-inspiring and elusive. But now, thanks to the James Webb Space Telescope JWST, we're seeing Saturn in a completely new light, literally. In its most detailed and revealing image of Saturn yet, JWST has given us a glimpse not just of the planet's surface and atmospheric layers, but of its dynamic ring system, enigmatic moons, and possibly the deep processes occurring beneath its cloud tops. Scientists are calling this a transformative moment in planetary astronomy. Let's explore what makes this image so significant, and how it could completely change our understanding of Saturn and its role in the larger story of the solar system. A glowing ring world, a view unlike any before. The JWST image of Saturn doesn't look like the familiar golden planet seen in Hubble or Cassini photos. Instead, Saturn appears almost surreal, a dark chocolate-brown orb encircled by glowing, luminous rings, shimmering like frozen halos in deep space. This image wasn't taken in visible light. It's a product of infrared observation, which allows JWST to peer beneath Saturn's hazy atmosphere and detect heat signatures from its surface and surrounding structures. The result is both breathtaking and scientifically groundbreaking. Infrared wavelengths reveal the composition, structure, and thermal behavior of celestial objects in ways that visible light simply can't. And for Saturn, a planet cloaked in thick layers of gas, methane, and clouds, this opens a new chapter in exploration. What's really going on in Saturn's rings? For centuries, Saturn's rings were seen as beautiful, static features, a decorative oddity of a distant planet. But the truth is far more fascinating. Saturn's rings are not a single monolithic structure, but a complex, dynamic system made of billions of particles, ice, rock, and dust, ranging in size from grains of sand to bus-sized boulders. JWST's image reveals these rings with a new level of detail. Instead of just seeing a flat disk, we now observe texture variation, and perhaps even signs of movement or interactions within the rings. Some sections glow more intensely, possibly indicating different material compositions, particle densities, or heat levels. More intriguing are the long-standing rumors and theories that the rings may contain phenomena we don't yet understand. Perhaps gravitational anomalies, unusual electromagnetic interactions, or even structures hinting at past collisions or cosmic events. The possibility of life in the rings? It might sound like science fiction, but speculation about complex organic chemistry or even primitive life-supporting conditions in the Saturnian system isn't new. Saturn's moon Enceladus ejects enormous geysers of water vapor and ice from its subsurface ocean, feeding Saturn's E-ring. These fountains, reaching heights of up to 10 kilometers, contain organic molecules, including phosphorus, an essential ingredient for life as we know it. Some theorists suggest that such an active system could, in theory, create microenvironments within the ring's dynamic, transient places where unique interactions happen. These aren't habitats in the traditional sense, but regions of complex chemical evolution, perhaps mirroring early Earth conditions. JWST's unparalleled sensitivity could help us detect trace gases, organic compounds, or thermal anomalies in the rings, clues that something remarkable might be occurring. Saturn's surface? A glimpse beneath the clouds. In JWST's image, Saturn's surface appears dark, even shadowy, except for two distinct brown-orange spots that glow more intensely than the surrounding regions. What are these? These bright zones are likely regions of higher methane concentration, as infrared wavelengths used by JWST are absorbed by methane gas in Saturn's atmosphere. This absorption pattern creates a sort of window that allows scientists to peer into deeper layers of the gas giant's atmosphere than ever before. Previous missions, especially Cassini, revealed Saturn's bizarre hexagonal storm at its north pole, and now, with JWST, scientists can analyze vertical structures, temperature layers, and gas distribution throughout the atmosphere. These findings could help answer a question long debated. Does Saturn have a solid core beneath its gaseous layers? Some theories suggest that a dense core made of rock or ice exists, surrounded by metallic hydrogen and other exotic states of matter. If so, JWST's infrared observations might be the first step toward confirming this. The mystery of Saturn's long seasons. One factor that makes studying Saturn so complex is its extremely long seasons. Saturn takes 29.5 Earth years to complete one orbit around the Sun, meaning each season on the planet lasts over 7 years. JWST captured this image near the end of a 7-year-long summer in Saturn's northern hemisphere. During this time, Saturn undergoes dramatic atmospheric changes. Temperature fluctuations, storm formation, and chemical transformations, especially involving methane and aerosols, are common. The bright edges visible in the JWST image could be caused by methane fluorescence or trihydrogen ion emissions, phenomena linked to solar radiation and atmospheric dynamics. Thanks to JWST, scientists can now monitor these seasonal shifts in real time and study how Saturn's weather and climate systems evolve over decades. Saturn's moons, Enceladus, Dione, and Tethys, in new light. The rings aren't the only stars of this show. The JWST image also captured 3 of Saturn's moons, Enceladus, Dione, and Tethys, hovering as tiny points of reflected light. But don't let their size fool you. These moons are dynamic worlds of their own. Enceladus is perhaps the most promising candidate for extraterrestrial life in the solar system. Beneath its icy crust lies a liquid ocean. Its geysers eject water, organic molecules, and now phosphorus, a key ingredient for life. Dione and Tethys, though less dramatic, have fascinating geological features, from canyons and ice cliffs to unusual impact patterns. Their surfaces may hold clues to past activity or even internal oceans. By studying the infrared emissions from these moons, scientists can better determine their surface temperatures, ice compositions, and potential subsurface activity. Beyond Saturn, JWST reimagines the outer planets. While Saturn has captured the spotlight, the JWST has also transformed our view of other gas and ice giants. Uranus. Previously seen as a bland blue orb, Uranus now shines with brilliant infrared rings and complex atmospheric patterns. The rings, nearly invisible in earlier images, stand out clearly in JWST's filters. These findings could help explain Uranus's tilted axis and unusual magnetic field. Neptune. Neptune's stormy atmosphere is brought into focus like never before. The planet's thin rings and its massive moon Triton, which orbits backward, appear with stunning clarity. Observations reveal heat flow, wind dynamics, and storm formation on this distant planet. Jupiter. Even the largest planet in the solar system looks new. JWST shows us unprecedented detail within the Great Red Spot, including vertical structures, temperature gradients, and hidden vortexes. These data will allow us to model Jupiter's weather and internal dynamics more accurately than ever. A new age of planetary science. What we are witnessing is a complete reimagination of our own solar system. The James Webb Space Telescope has not only turned its gaze toward the edges of the early universe, but is now transforming our understanding of our cosmic neighborhood. From the rings of Saturn to the storms of Neptune and the glow of Enceladus's geysers, JWST is peeling back the layers of mystery, revealing that our planetary system is far more dynamic, diverse, and alive than we ever imagined. As the data continues to come in, and as JWST turns its eye to other moons, planets, and even exoplanet systems, we stand on the edge of discoveries that may one day answer some of the oldest questions ever asked. Are we alone? How did our solar system form? And what secrets still lie hidden in the cold shadows of gas giants and icy moons? Stay tuned. The universe is just beginning to speak.